So here is the process explain how the encryption part is done in our project. Firstly, we have utilized the S box for the generation of encrypted key, and I just wanted to explain you what is the main purpose of an S box, that why we are utilizing this S box. As an S box is a substitution box and it is the only non-linear component in the cipher, so its main purpose is to obscure the relationship between the key, the plain text and the ciphertext. Basically, in our previous researches, we have used the linear components, linear techniques in order to establish the relation, the encryption and the decryption part. So it is very much easier for the third party to easily tackle our key and to hack the information. So in this project, we have proposed to use the non-linear components such as SBox, so that it will directly create a confusion using the process with SBox. It will directly create a confusion between the third party. So now total we are having, firstly we are having 14 rounds of encryption, that is add round key, sub bytes, then shifting is performed, and then multiplication of column, then again. So total we are having 4 processes which will be repeated in all 14 rounds. So now firstly for encryption part round 0 we are having the add round key process will be done first. So for this we are having 128-bit plain text. 128-bit plain text, you can see over here that it is a 4x4 and it is 128-bit matrix. Here each cell of the matrix consists of 8 bits. So total we are having 8 bits, that is 8, that is 4x4 matrix, so it will be of 128-bit total. So and we have utilized, as I have already said, we have utilized SBox, so which is a 16x16 matrix. This, you can see this one, this is the 16x16 matrix. This, it resembles all the elements of 16x16 matrix of SBox. So what we have done in our first process, like as we see the 128-bit plain text, so the element which is lying at the first, at the 0th row and 0th column, we are looking up in the lookup table. Lookup table is nothing but the S box. So the element which is residing on column row 0 and column 0, we are picking that element and placing it into this matrix, into 4x4 matrix, that is, it will be the, yes, with this matrix we are putting into, like I will show, row 0 and column 0, the element is, you can see here, row 0 column 0, 63 is lying, so we have substituted the element 63 in place of 0 and 0 element. And similarly the process will repeat for each and every element of the plain text matrix. We are going to replace the value which is lying at ith row and ith column in this. So like the element which is lying in row number 1 and column number 2 we are placing over here, C9. So you can also see this thing, C9, C, this one is C and 9. You can see clearly what is lying, C9 is lying, you can see. Like this whole process is repeated for total 4x4 matrix. So the output we will obtain in after performing the add round key operation, that is, firstly we will XOR both the elements, that is the element which is lying at the row at the index 0 in we'll XOR the elements, like the first row and first column of both the matrix we are going to XOR, like 0 0 will get XORed with 63 and 12 will get XORed with C9, and then 0C will get XORed with FF. Likewise 08 will get XORed with 30. So I have used the functional calculator, that is the scientific calculator I have used to estimate the values of these XOR values. So the output we have got or 0 0 is XOR 63, we have got the output 63. For 12 XOR C9 will come as DB, and 0C XOR FE will come as F2, 08 XOR 30 will come as 38, and likewise for whole 4 cross 4 if 128-bit matrix we have got the new 128-bit state matrix. So now as we have got the output of round 0 of encryption, so that output we will carry as an input to the next round. So next round we are having subbytes operation. So the output which is got will initially serve as the input for the next operations, that is subbytes. So now we will see so this is the input to the subbytes. So now we will check that substitute the values again from lookup table, that is SBox. So element which is lying on the row number 6 and column number 3 we will check and then in the lookup table and then write the value over here. Like 63 is there, you can see where is 63, this is 6 and this is 3. So F8 FB it is lying, FB 63 FB is there. FB is there. In phone it is not visible so much, so I am unable to show. So FB, likewise DB, we will check the dth row and bth column and then replace the value from the lookup table, that is substitution box. So we will get the value such as B9. So F, likewise for F2, F row number F and column number 2 we will substitute the element 89. So like this substitution bytes operation will be performed. So we will again get the initially 4 cross 4 matrix like this, and then after we have got this matrix as an output, again this matrix will serve as an input to the next round, that is shifting will be performed to the state matrix obtained in the round in the step number 2. Step number 2 is nothing but this subbytes operations output. So input to the shifting matrix is this one, this the output which we have got from the subbytes. So now we are performing the shifting operation to this matrix. After shifting the mixed column operation is performed. Okay, so for shifting, firstly we are shifting the these element will be shifted one row left side, these element FB. So FB will come here, that is 07 will come over here, 07 then FB then B9 then 89, like this whole element will be interchanged, and after this we have we need a state matrix. So let's say the output we have got after shifting, we have got this output. Okay, so this output we will get after shifting 0 1 2 3. So now we are performing the last operation such as mixed column operation. So we will again multiply both the matrices. Multiplication will take place in such a way that we will XOR each and every row with each and every column element. Like firstly we are XORing we are multiplying FB into 0F and then XORing, then the output which will come, we will XOR this both FB9 into 26, then 89 into 56, then 07 into 0F. So this we will get the output. So for the first row, and then similarly for the second row, 42 into 56 XOR FB into 0F and 92 into DB and XOR 42 into 86. Like this we are performing for whole 128-bit matrix. So after the XORing result is being obtained, we can see the 3 XOR symbols. So one by one we will XOR these two both, then the output which will come, we will XOR the both output, like the output of FB into 0F XOR D9 into 26. The output, this out after this output will come, we will XOR with the output that will come after XORing these two elements, 89 into 56 XOR 07 into 0F. So after this XOR we have got, now firstly I have multiplied, so multiplication output is this EB5. Then we can see again 3 XOR symbols are there. So firstly I have multiplied only in this step, then in another process I have XORed these two elements using the scientific calculator, which is easily available in the internet. So EB5 into XOR 1FCC, so like this whole XOR operation will be performed, and we can see at the last only one XOR is left. So finally we are XORing these two elements also. So 1179 XOR this. So final we can see 4 cross 1 as the output matrix in the round 0. After the round 0 all operations are completed, we are getting this cipher key we have obtained. So after this process will be performed for whole 14 rounds. This is only round 0. And last 3 rounds, that is last round only, round number 14 will consist of only 3 processes. Their mix column will be missing. So after that 14 rounds we will get the total final encrypted key, which will be used as the input to the decryption end. So after we have got the output from the encryption side, we will serve as an input to the decryption end. That is